this class, we will quickly simplify this DC network having dependent source by applying the concept of KVL and KCL, that means mesh analysis and node analysis. Now in this given circuit, we can see we are having here two dependent current sources. From this arrow, we can identify that this is a dependent current source. The value of the current of this current source is 2I1, where as I1 is the current flowing through this 2 ohm resistor. So the current value of this current source depends on the current value through this resistor. I have already explained about all these various types of dependent sources in my separate class, so you can refer that class. Again, the current value of this current source, we can see here it is 2I2, whereas this I2 is the current flowing through this 2 ohm resistor. So this is again a current dependent current source. Now for this DC network, finally we have to find the value of VL divided by Vs, that means the ratio of the voltage drop across this load resistor and the voltage of the source. Now the voltage value of this voltage source is given as 10 volts. That means the unknown parameter to find this ratio of these two voltages is VL. So if we can find VL by simplifying this circuit, then we can easily find the ratio. So let's proceed. Now in this circuit, what we can see is we have a parallel branch here of two resistors. Each of them has the value 2 ohm. So instead of this parallel branch, we can think of their equivalent resistance value, which will be connected in series with this voltage source finally, and that will be 1 ohm. So in place of this parallel branch, we can think of a simple resistor that has resistance 1 ohm, which is connected with this voltage source in series and with rest of the circuit. Now if we look closely at this voltage source, this resistor and this resistor, load resistor, then we can find that these three components actually forms a loop or mesh. So we can easily apply KVL or mesh analysis for those three components. Now if we apply KVL and if we move from this side, now here for this voltage source we are moving from negative terminal to positive terminal, so that we can take as positive voltage. If we go by that convention, then this will be plus 10. Then for this resistor we are moving from positive terminal to negative terminal, so that voltage drop will be taken as negative voltage as per that convention. So here it will be minus, so it will be IS, that is the current IS, and then multiplied by equivalent resistance, which is 1, and then minus, again we are moving from positive to negative terminal, so it will be minus VL, the voltage drop across that load resistor, and that will be equal to 0. So we can finally represent VL in terms of IS as 10 minus IS. So if we can find the value of IS, the current supplied by this source voltage, then we can find the value of VL and we can easily find the ratio of VL and VS. Now if we look at this parallel branch which has two dependent current sources, then we can easily see that both the current sources are flowing, the currents are flowing in the same direction. So the current value I here will be the sum of these two current values. So we can write that current value I will be equal to 2I1 plus 2I2. Now again at this node, if we apply node analysis, then we can see here at this node we have three branches. Now to this branch the current which is flowing is IS, to this branch the current which is flowing is I, and through this branch the current that is flowing is IL. The IS and I, they are entering that node, and IL, this current is leaving that node. So as per the node analysis, the algebraic sum of all these currents will be 0, or we can say the sum of all the incoming currents to a particular node will be equal to sum of all the outgoing current from that node. So here we have two incoming currents, IS and I. So IS plus I will be equal to IL, because for this node we have only one outgoing current. IS plus I, that will be equal to IL. Now again if we look at this part of the circuit, what we can see at this node, main current or source current is getting divided into two parts, I1 and I2. So if we apply node analysis at this point also, then what we can see that with respect to this node, IS is the only incoming current and I1, I2 are two outgoing current. So here again the relationship that we can develop, IS is equal to I1 plus I2. That is another important relation between the currents that we are developing by applying node analysis. So this relation, if we put here, then what relation we are getting is, in place of I1 plus I2, we can replace that value by IS. So the important relation that we are developing between I and IS is I is equal to IS. Now again, if we apply mesh analysis for this outer loop, what equation we will be getting? It will be minus 2 plus, so it will be Vs. Then in place of this parallel branch, what we have seen that we have a single resistance having value 1 ohm. So it will be minus Is into 1, and then we will be having this voltage value which is minus IL into 5, and that will be equal to 0 because IL is the current flowing through this resistor having resistance 5 ohm. Now the value of the voltage source is 10 and this will be Is finally, but we don't know the value of IL here, but IL we can represent in terms of Is and I, that we have already developed the relationship, and this is the relation. So in place of IL we can write Is plus I and then multiplied by 5, which will be equal to 0. We have developed a relationship between I and Is, and this is the relation I is equal to 2Is. So we will use that relation here. So finally it will be, so we need to further simplify this equation to get the value of Is. So the value of Is will be 10 upon 16, which will be equal to 0.625 ampere. So now we have obtained the value of the source current, which is 0.625 ampere, and if you remember, we already developed a relationship between the load voltage and the source current. So if we now put the value of Is in this equation, we will get the value of VL, and what we needed to find was the ratio of VL and Vs. So VL is equal to 10 minus Is. So this value will be 9.375 volt. So what will be the final ratio of VL and Vs? So final value will be 0.9375. So I hope this class was meaningful for you. With that, hope I end today's class. Thank you.